All right, in this video I'm going to show you about drainage basins. So when we're looking at drainage basins, take a look at the tips over here for reading contour maps. In this map you can see the ridges and the valleys. The little blue here means that there's water. This is the same one that I take from Navisite. So you can see this low-lying area here. That is where the water is going through this path here. Now this purple area is where the basin is, and you can see the roadway. This little road here is actually this one right here. You can see Bow Lane, and you can see Westwind. This is Westwind Road right here, and Bowwind's here. So what we're seeing is this basin, this white area, is our drainage basin, and you can actually see it from the topographic relief map here, our basin. So there's a ridge line through here. It comes down. Here's my low-lying area, and then comes back up and follows through here. All the water drains down to this lower basin area here. So the tips for reading the contour map is all of the flow paths have to be perpendicular to the contours, and I'll show you contour maps in a minute. Make sure you know what streams look like. They're going to look like concave V's. The V depends on which direction you're looking at it. Ridge line, think of it as a convex or a nose type of rounded area. Make sure you understand where your peaks are for your mountains, or even low-lying areas for swamps. Usually the swamp areas are shown as little circular features. Take a look at a USGS map sometimes. Contours that have steep slopes have contour lines that are really close together. Contours that are more flat have contours farther apart. Make sure you know where your rivers and your streams and your creeks are, like this one. That'll give you a point of interest on most maps. It says to ignore roads. Ideally, construction shouldn't shift drainage. Typically, roads are boundaries unless we're looking at a road for where we're going to put our drainage pipes. So the steps for delineating a drainage basin is find your point of interest, identify the ridges and the valleys, and then draw from hilltop to hilltop. So let me show you a few examples to get you started. So here's a residential area. There's an inlet that I've got some interest in over here, and I've got a road over here. Okay, so if these are inlets already that are in the road, typically we don't put water onto the property next to us. So this is going to be one of our boundaries. The other thing is roads are usually crowned. That means the center line is the highest point and water goes to the inlets. Usually there's inlets on both sides of the road, unless it's an inverted crown and then the inlet is in the center of the road. Now, so I'm going to follow the center line of the road up, and then I'll notice that I've got contours. So if I'm looking at this, and let me get my pen, if I draw a line through here, cross-section wise, if this contour right here is 310, and the next one up is, we'll say, 311, then I've got a 310, a 311, and a back to a 310. That means it's going like that. So same with here. If I drew the contour this direction, or the cross section through this way, there's 310, there's 309, 309, and then back up. And then this one would actually be drawn like that. So it would be this would be a valley, or where water is collecting and pooling. So you're always drawing, notice you're always drawing perpendicular 90 degrees to the contour line. All right, usually residential areas are harder to delineate unless you're actually creating the drainage basins yourself. All right, let's take a look at your time of concentration flow path. Let me erase this out of here. Okay, so the flow path is the highest point on the site. So here is my highest point on my site, and it's going to go perpendicular. It's the same like the drainage basin. It's going to go perpendicular to our contours, and it's going to be the most hydraulically remote point. Not the furthest point, but the one that's going to take the water the longest to get there. So it's going to come down here, perpendicular to the line. It's going to hit the road, and then it's going to follow the edge of the road down all the way to the inlet. So in this picture, the center line of the road usually is the crown, and water flows that direction, and then the water is going to flow off that direction. All right, let's take a look at the next slide. In this slide, we'll go ahead and talk about the drainage basin. We have a point of analysis, so I'm going to take this back out for a quick second. So we have a 1500 and a 1400, so 14, so it's 2, 4, 6, 8. So these are in contours of 20. So if I drew a line, again, if I drew, oops, get my pen back. If I drew a cross section through here, I would go 1400, 1420, 1440, 1440, 1420, 1400. So it would go up and then back down. So my ridge line is through here. Now, the area that's in between these two contours, we don't know what that is, but we're going to assume if water hits on this side, it's going to roll down that direction. This area here would be what the saddle is, so you would bring this around, hit the high point, stay in between, hit the high point. Now here's the thing is you could follow this down, but that gives you a secondary. Notice that this is my point of analysis. If I take this one down, I'm actually taking into this low-lying area here. So when we're looking at this, we're also taking into account, let me change that color to blue. Here is where our point of interest is. See the line and then 3 dots? That means that's water, or that's a stream of some sort, and we're going down. Remember what I said about the V's? So looking at it this way, there's a V, there's a V, there's a V, but over here's a V also. So that means water's going that direction, okay? But since that's our point of analysis, this one goes all the way past our point of interest, so we know that this is incorrect. So we have to come over here and go back to my pen. I'm working with using pens, so I apologize. And I'll go back to the red. So it needs to come through here and then come back around. All right, so I'll go to the next. I'm going to go ahead and get rid of that ink off of there so you can see it a little bit better. So that is my ridge line. Now, the next thing is there is the most hydraulically remote path. But here's the thing, is this is all channel. And if you remember from the previous one, that channel means water's going to go faster. So the most hydraulically remote point is actually on this side. Okay, so if I'm going to erase that. If I look at the next, so that's one path, but this is an actual longer path because the slope here is much flatter than this slope here. So I would say this is my most hydraulically remote path for my time of concentration. All right, I'm going to pause here and then we're going to go over the next example.